Assalamualaikum warahmatullahi wabarakatuh. For today's lecture, this is week 4. We are going to learn on RC slab design, part 3, which is two-way spanning slab. Course outcome is CO2 PO3, which is we need to compute a design solution for engineering problem. And the learning outcomes at the end of this lecture, you should be able to differentiate between simply supported and restrained two-way slab. Then you need to compute and draw the bending moment diagram. And also, you need to compute shear force for the slab and design the slab according to EC2. Okay, for conventional reinforced concrete slab, so we have two types of slab, which is one-way slab and also two-way slab. For one-way slab, it deflects in one direction only, and the Ly, the length over width ratio, is greater than 2. For longitudinal reinforcement, we provide only in one direction. So it means you design only in one direction, which is the direction of load transfer. For two-way slab, the slab will deflect in both directions, and the length over width is actually less or equals to 2, and then you need to provide longitudinal reinforcement in both directions. Okay, so means you need to design in LX direction and you need to design in LY direction. Okay, let's recap on one-way slab. For slab supported by 4 edges beam, the load transfer for one-way slab is in one direction, and the load is going to the long beam. So this is beam in LY, which is longer beam. So the load transfer is this way. Okay, so you have to draw your 1 meter strip according to your load transfer direction. Okay, so you get that when you calculate your Ly over Lx, you need to make sure that it is greater than 2. Then you can design as one-way slab. Okay, so which is the L value is equals to Lx value. Okay, so based on this 1 meter strip, so L is equals to Lx. This is for one way, which is Ly over Lx greater than 2. Okay, so next is for two-way slab, which is slab is supported by 4 edges beam. So load transfer is in both directions. First of all, you need to make sure that Ly over Lx of the slab is lesser or equals to 2. So then it becomes two-way slab. Okay, so the slab distribution, the load distribution in two-way slab, for longer span, the shape is trapezoidal shape. Okay, so while for shorter span, the shape is in triangle shape. Okay, so the angle is 45 degree. Since we have load transfer in both directions, so we need to draw our 1 meter strip in both directions. This one is for Lx direction and this one is for Ly direction. Okay, so since we have two 1 meter strips, so it means that we have to design 2 times. One in the Lx dimension and another one you have to design in Ly dimension. Okay, so the L is depending on the which side that you are going to design. Alright, so now we move on to two-way simply supported slabs. Well, for two-way simply supported slab, it means that Ly over Lx is less or equals to 2, and the slab only have one panel, which is all side of this slab panel is discontinuous. Okay, it means that the corner will tend to leave and cause torsional moment. To calculate moment, for this type of slab, simply supported slab, the movement only occur at the center. So we have movement in X direction and also movement in Y direction. Okay, so to calculate the movement, we are using a formula given in appendix page 20, which is MSX is equals to alpha SX and LX squared, or MSY equals to alpha Y and LX squared. So N is the total ultimate load, or W. N is actually W value, UDL value, and the LX is the length of the shortest side, LY is length of the longer side, and alpha X and alpha Y are the moment coefficient that we get from the appendix. So in the appendix, we have table 3.13, which is bending moment coefficient for slab in two direction. So based on your Ly over Lx value, so you get your alpha x and also alpha y value, and it depends on your Ly over Lx. So let's say you get your Ly over Lx is equals to 1.25, for example. So it means that in between this value, so you need to interpolate to get the exact value of the alpha. Then you substitute the alpha value inside your equation to get the value of moment and for X direction, and also the value of moment in Y direction. So please take note here in the formula, they are using Lx for both moment, MSX, MSY. Okay, so the N value is the UDL, which is, or we denote as W. Okay, for shear force, we just calculate using this formula, which is the UDL value times the distance divided by 2. Okay, so and then you draw your shear force diagram and bending moment diagram for simply supported. For simply supported, since the moment is only occur at the center, so it means the SFD and BMD is actually similar to simply supported one-way slab. It's just that you have to draw in both direction, one for MX direction and also one for MSY direction. Okay, and then we follow the design steps. Since first you need to calculate your design load calculation, and then you draw your SFD and BMD based on the value that you get from the table. Then you can determine your nominal cover and effective depth value. Then you can design your main reinforcement. So for main reinforcement, it means that you have two value, which is for MXS value and also for MSY value. Okay, so for shear resistance check, so for this one, you just take for V maximum value. Check for V maximum value. This one, you only check for shorter span, Lx. Okay, so you just check for short span. But for crack checks, you need to check for both direction. And don't forget to draw the detailing. So detailing will be covered in next topic. Okay, so another type of two-way slab is restrained slab. So what it means by restrained, it means that a part of the slab is continuous with others, which is, for example, let's say this one, this for the left side is actually continuity of the slab, so it becomes continuous, and here is also continuous and. So it means that when you have continuous and you have moment value, or negative moment value. And also for this side is actually, for this panel is actually in the corner. So this side is discontinuous and discontinuous. Okay, so you need to make sure that Ly over Ls is less or equals than 2 so that you can design as two-way restrained slab. To get the bending moment for restraint slab, we are using a table in appendix page 21. So the formula is given as this one, which is we have two formula, MSX, beta SX, and LX squared, or MSY, beta SY, and LX squared. Okay, for beta, we get it from table 3.14 in appendix page 21. Okay, in table 3.14, here is actually your ratio Ly over Lx value. So based on your Ly over Lx value, you will get your value of coefficient for the moment, beta Sx or beta Sy. This one is for shorter span. This side is actually for shorter span, which is you get here is beta Sx. And the last column is actually for long span, which is you get here is beta Sy. Okay, from table 3.15, first you need to identify the location of the panel or slab panel that you are going to design. For example, we have this one is case number 1 is for interior panel. So it means all side is continuous. And then you have one short edge discontinuous. So means that here one of the LX is discontinuous. So you need to identify which case for the slab belong to. So then we can get our coefficient. Okay, so let's say we take one example. So for the case number 1, Ly over Lf is 1.5. Then you get beta Sx equals to 0.053. And it mentioned here that negative moment at continuous edge. So this one is only for continuous edge. Okay, so and then positive moment at midspan. So means this value only occurred at the midspan, positive moment. Okay, and based on previous figure, so it is case number 4, which is two adjacent edge discontinuous. So then let's say if you Ly over Lx is 1.5, then you are going to use negative moment 0.078 beta Sx and 0.09 beta Sy, beta Sx, and for beta Sy you get these two values. So altogether you have 4 values or 4 moments for each side. Okay, for restraint slabs, we have 9 different type of support depending on the location of the panel that you are going to design. For example, for case number 1, 4 edges continuous. So this is case number 1. The yellow panel is actually indicate the slab, and the white panel is void. Okay, so for case 1, it means that they have slab for each side of the panel. So it means it continuous at all edges. So that is what we call as interior panel. And then for case number 2, one short edge discontinuous. So this is case number 2. This is short edge. So this short edge is discontinuous, which is you don't have any slab at this side. So it is discontinuous. Okay, so and then another one, let's say we take a look at case number 7. So here case number 7, this is void, and also void. So it means that 3 of the edges is discontinuous and only one long edge continuous. So that is case number 7. Okay, so you need to choose which case for your panel before you can design and calculate the bending moment values. Okay, so next you have to design your draw your SFAD and BMD for restraint slab. So let's say we take case number 4, which is two adjacent edge is discontinuous. So means here this side is discontinuous. Okay, so that, and the other side is continuous. Okay, so this side is continuous. So for continuous edge, they have negative moment. So here is negative moment. And at the midspan, you have a positive moment. So then you draw your SFD diagram. You have to draw for both sides, which is x direction and also y direction. To draw this bending moment diagram, you just need to follow the sign of the moment. For example, let's say for this one, for Ly, so here we have negative MSY. Then at the center, we have positive MSY. So, and this side, since this side is, the left side is actually continuous. So here we have negative MSX. The other side is discontinuous. So this one is 0. So then you have a moment at the center. Okay, so how about the shear force diagram and bending moment diagram for other case? So you have to draw for all cases. Okay, so I need to see for all cases the BMD and SFD diagram. So next is for the shear force. For shear force, the formula is given for beta V. V means for shear and Lx. So not Ls squared because this one is shear, so the unit should be in kilonewton. Okay, so based on the load distribution, so here is the load distribution of two-way slab, trapezoidal and also triangle. So the trapezoidal side is for beta Vx and triangle side is for beta Vy. So based on table from appendix page 22, okay, so here is for beta x and here is for beta y. So you need to substitute the value based on this table. Okay, depends on your cases. For example, let's say we have case number 4 and our Ly over Lx is 1.5. So we have this value for beta Vx. So how do we know which one is continuous edge and discontinuous edge? So it depends on our panel. So for example, here is continuous edge and the other side is discontinuous edge. For continuous edge, the value is 0.54 for beta Vx. For discontinuous edge, the value is 0.35. And for beta Vy, for continuous edge, the value is 0.4. And for discontinuous edge, the value is 0.26. Okay, so then you substitute the value of beta Vx and beta Vy into this equation. So then you identify your VED or V maximum. Once you get your VED value, then you can check for shear. Okay, for effective depth for two ways, since we have two main reinforcement, one in X direction and also in Y direction. So the calculation of effective depth, the D value, is depending on the reinforcement. Let's say you are going to calculate for X direction. So means you calculate dx. Dx is bottom reinforcement, so which is the blue one. So the ds value is equals to total height of the slab minus cover minus diameter bar divided by 2. But for dy in y direction, since we have a main reinforcement in x direction at the bottom, so our main reinforcement in y direction is basically located on top of the x direction. So you need to take the distance from top to the center of main reinforcement in y direction. So which is dy is equal to thickness of the slab minus cover minus diameter bar in x direction minus diameter bar in y direction divided by 2. Okay, so and then you can follow complete slab design step one by one until the crack check. Alright, so basically that's all for two-way simply supported slab and also two-way restraint slab. And we are going to look into one example later on. Okay, thank you very much for listening.